Hello grade 10. So we're just going to start off with a little recap of lesson 3.8, which we learned right before the break. I'm just going to refresh your mind on how we did factoring so that you can use it in the next lesson properly. So when factoring, we ask 4 questions. First we ask, is there a greatest common factor? And if there is, we take that out first before we try to factor any further. Secondly, we ask, is this a difference of squares? So that would be 2 perfect squares separated by a subtraction sign. So for example, 81. And then you would just take the square root of both. So the square root of x squared would be x. Put that in each bracket. The square root of 81 would be 9. Put that in each bracket. Add 1, subtract 1. The third question, we say, is this a trinomial? Of the form x squared plus bx plus c. So in front of the x squared, there's no number, meaning the a value is 1. Or the last question we ask, is this a trinomial of the form ax squared plus bx plus c. So that is when there's a number in front of the x squared, so the a value is not 1. All right, so let's do some examples with these questions. So number 1, y equals 2x squared minus 16x. So the first question we ask is there a greatest common factor? Is there a number we could divide out of both terms? And in this case, both terms are divisible by 2 and by x. So we'll divide each one by 2x. We need to place that 2x in the front of our equation now. 2x squared divided by 2x is just x. And 16x divided by 2x is 8. And we're subtracting. So now this is completely factored. We have no more squareds, and we could find the zeros if we wanted to by setting each section equal to 0. So 2x equals 0, divide both sides by 2, therefore x equals 0. X minus 8 equals 0, add 8 to both sides, so x equals 8. Second example is y equals x squared minus 25. So first we need to check for our greatest common factor. No, there's nothing we can take out of both terms. Next, we need to ask, is this a difference of squares? So are both terms perfect squares, and are they separated by a subtraction sign? Yes, they are actually. So then we take the square root of x squared, which is x. So we put an x in each bracket. We take the square root of 25, which is 5, put that at the end of each bracket, and then we add 1 and subtract 1, and that is completely factored. The third example, y equals x squared plus 3x plus 2. So is there a greatest common factor? No. Is this a difference of squares? No. Which brings us to the third question, is this a trinomial of the form x squared plus bx plus c? So is there a number in front of x squared? No, there's not. So that means that the a value is 1. So in this case, we need to find 2 numbers that multiply to c, which is 2, and add to b, which is 3. So I'll write that out. Multiply to 2, add to 3. So what are some factors of 2? What numbers multiply together to equal 2? Well, our only options are 2 and 1, and those do add together to equal 3. So that means we have x plus 2 in one bracket, x plus 1 in the other bracket, and this is completely factored. Example number 4, y equals x squared plus 5x plus 4. Again, our a value is 1 because it's not there. So we do the same thing, two numbers that multiply to 4 and add to 5. So some factors of 4 would be 1 and 4, or 2 and 2. And then we need to say which combination of these numbers adds up to 5. Well, it's going to be 1 and 4. So in our bracket, we'll have x plus 1, x plus 4. And that's completely factored. Number 5, y equals 3x squared minus 13x minus 10. All right, so in this situation, the number in front of x squared is not 1, it's 3. So this is the fourth example. Is this a trinomial of the form ax squared plus bx plus c, where the a value is not 1? Yes, it is. So in this situation, we need to take the a and c and multiply them together. So 3 times negative 10 equals negative 30. And now we need to find two numbers that multiply to negative 30 and add to negative 13. So in order to get negative 30, we need to have one positive number and one negative number multiplied together. So we could have negative 1 times 30, or negative 30 times 1. We could have negative 2 times 15, or negative 15 times 2. We could have negative 3 times 10, or negative 10 times 3. We could have negative 5 times 6, or negative 6 times 5. Which combination of these adds together to equal negative 13? Remember, you have to take into account that some of these are negative numbers. So the combination would be negative 15 and positive 2, because negative 15 plus 2 would equal negative 13. Now we need to take those two terms and replace the negative 13x with those two terms. So we'll have 3x squared minus 15x plus 2x minus 10. And we're allowed to do that because negative 15x plus 2x equals 13x, which is just what we replaced it with. Now we're going to group these into two groups and take a common factor out of each group. So the first group, 3x squared minus 15x, we could take out a 3x. Now we'll have x minus 5. And the second group, we could take out a 2, so we'll also have x minus 5. Remember, that's the goal. You want to have these two brackets to be the same so that we can combine them into one bracket, and we'll have 3x plus 2 from here, 3x plus 2, and they're both being multiplied by x minus 5, and that's factored. Number 6, y equals 6x squared minus 7x minus 3. So again, our a value is not 1, so we need to multiply 6 and negative 3, which is negative 18. We need two numbers that multiply to negative 18 and add to negative 7. So that would be negative 9 and positive 2. Negative 9 plus 2 is negative 7. So we'll replace the negative 7x with negative 9x plus 2x. And then we will group them and factor out a common factor from each group. So the first group, we could take out a 3x. We'll be left with 2x minus 3. The second group, we can't take anything out, so we just take out a 1, and we'll be left with 2x minus 3. Now we'll combine these into one bracket. 3x plus 1 times 2x minus 3. Okay, so that's just a little refresher of what we learned before the break. So now you need to go to Teams and complete the open book quiz about factoring and hand it in on Teams, and then do lesson 3.9. All right, have a good day and let me know if you have any questions.